Can everybody hear me? I know that some of you have spent 4 hours on an airplane to come here, and all of you have put out considerable effort. And I want you to know that I've done the same to make it up to you, to give you a presentation equal to the other ones, or at least partly equal to the ones you're hearing from the other presenters. I want to make it not only informative, but interesting. So here we go. These are called, as you know, cell wall deficient, but this was given them to a committee who wasn't very thoughtful, I think. Cell wall divergent would be much better for these, because they can have a thick wall, or they can be so tiny that they're like a filterable virus. In certain conditions, the majority of the bacteria there are virus-sized. So I like the term for these L forms. It was given to them to honor Lister Institute, but I like to think of it as standing for large and little, because you have such great diversity. These can be so big that in one species you can see them macroscopically, and that, of course, is a phenomenon. This is Almquist, who spent his lifetime as an epidemiologist, but as a hobby, he studied cell wall diversity of bacteria. And he had been in the labs of both Koch and Pasteur. Koch and Pasteur had seen these, and they knew they were virulent. But Almquist is the one who wrote a lot about them. And he said one lifetime wasn't enough time to see all the variation that a single species could have. So we would be completely lost if it were not for fluorescent antibody, which incidentally was developed by my mentor, Cora Downs at the University of Kansas. So we use fluorescent antibody constantly. This is just to show that you have diversity in one of the famous organisms these days, Morelia Burgdorferi. These are spheres. So in any culture of spirochetes, you have typical filaments, and then you have little round forms, and the Germans call these cysts. So you're going to hear a lot about cysts in the next hour. And here are some big ones reacting with fluorescent antibody. And it doesn't matter which spirochete this could be. I'm pretty sure this is a Burgdorferi, but it could be the other 4 spirochetes we're going to feature during this hour. The importance of recognizing these, of course, you can get a rapid diagnosis in diseases that otherwise conditions the organism grows out. The most important example here is tuberculosis, and we'll show you some slides to show you that we can grow it infallibly in 48 hours. The Russians, they're always getting ahead of us, you know. They got to the North Pole before we did, but anyway, they get ahead of us in quite a few things, and this is one, perhaps. They have a method that in direct smear, they see the L form of the tubercle bacillus from the blood in 80% of the cases. Well, ours is 100% in 48 hours, as near 100% as anything in medicine is. So I think we'll have to stay with my method until the Russians publish better pictures of theirs. Theirs so far have not been photographable. They've sent us photos, but they're not even good to look at, let alone print. So that's a matter of time. But they do have a method for rapid diagnosis, and this is from the the Hospital of Bacteriology in Moscow. So you can get positive cultures where otherwise you wouldn't get them, and you get them earlier. And you can find them in mixed cultures. And what else, Sandy?
Well, it's detrimental in the Detrimental and the beneficial. What are the beneficial things? Beneficial things that you get out of alcohol.
Oh, I know that. You read the last line in this. That's put in as a joke, of course. There is a cell wall deficient streptococcus that is pathogenic for the fruit fly and for Drosophila. So that's one benefit. I should say that there is a huge literature, too, showing that these can be used as vaccines and even therapy for cancer. But a lot more needs to be done on that. But it is something that is going to happen, probably. And look at the diseases. I don't think we're leaving out anything. They're all, in all of these, in some cases, this has been the only thing that's been found. Not only was it found earlier, but it was the only thing that was, only organism that was found. And this is true for a great many fungi as well as bacteria. And this is the organisms, the bacteria and fungi that have been found occurring in pure culture in disease. The list from veterinary medicine is growing, and it would make this enormously longer, maybe twice as long. This is the pathogens continued. There were too many to fit on one paper. This is an example of mixed culture. This happened to be Staph aureus and E. coli, but one of these could only be detected with fluorescent antibody. So if you have a lot that's stained with one antibody, you've got to look and find what the other organism is. Well, this is Almquist's idea, carrying out one of his things he noticed. You've all seen Escherichia coli. You remember your course in micro. It's a simple little gram-negative rod. Well, look at the way it can look when it's been inhibited by antibiotic. And this is the same Escherichia coli, and these are different colony types. It would certainly help if you could look at a plate and say, oh, those are typical colonies of such and such. You get a clue, but you certainly don't get the complete answer, because look at all the possibilities. When we skip a space, it doesn't mean anything's happened to the camera. It's just that it's a new topic. Well, you can, this is important in the food industry if you're trying to see if a product is contaminated with salmonella, for instance. If there's been a food outbreak and you're trying to see which food was incriminated, you're going to get an awful lot more of the little fellows than you do the classic. This is something my students did. They stayed up all night on more than one occasion to do some research. If anybody in this lab wants to see what cell wall deficient organisms look like, just look at early growth. Don't wait 18 hours. Look at growth as they develop. And this is all the things that were seen in a perfect medium for Staph aureus, a typical strain of Staph aureus, and look at all the little tiny fellows. So another way to look for cell wall deficient organisms is around an inhibition disc on a Kirby-Bauer plate. You put on penicillin or some other antibiotic for inhibition, and you get a nice zone of complete, it looks like complete inhibition until you look closely. And then very frequently you will see some intermediate called colonial growth, and that will be the variants. So it's not too hard to find these. Well, this is what happens when the diagnosis isn't made in time. This was a baby who was contaminated in delivery. The mother's genitalia were contaminated, they think. Anyway, if they had looked hard at 24 hours, they would have made a diagnosis, but they didn't get the answer till it was too late. And then we get to, this is tuberculosis. When they didn't think she would have facial tuberculosis. This is what the clinic has to know. The tuberculosis can occur in any body part, including the genitalia, including the skin on the back, any tissue. This is something my students taught me. If I have any great intelligence, it's what my graduate students have taught me. I had such wonderful ones. And one of them pointed out that whenever you have a severe infection, the blood is loaded with the L form. And this could have been found if they had just looked and not looked just for classics, but also for the variants. To reassure you, this woman, thanks to plastic surgeons, was restored to something that looked like normal. Nobody would have recognized her, but at least she had the relief of looking pretty human again. This is what happens in the typical case of pulmonary tuberculosis that isn't diagnosed in time. You notice it said the diagnosis here was made in 8 weeks. That's how long it took for the organism to grow out in those yellow high colonies in Petrogoni slants. But if they had looked in the blood at a 48-hour blood culture in any medium, you will see this. These are L forms. It's a broken up colony, but the morphology is great. It's you look at the edges. If you've ever worked with actinomycetes, you'll see actinomycetes are made of curved slants, rods that branch, and that's what these look like. So in any blood culture medium used in the United States or all over the world, at 48 hours you're going to find these. And if you want to look for L colonies in blood, we'll tell you some other things that help in cultures. You can do something called a Cylon Float, and of course this is in my book, but you take even 2 ml of blood, even 1 of a blood culture, and you put in 1/10 of an ml of xylol, and cell wall deficient organisms have a high lipid colony, and do other bacteria in general have more lipid than you'd think. They all move into the xylol phase, and so when you shake this for about 5 minutes, and then you leave it for an hour, and go away and come back and tilt it and get your xylol down in a corner and take it out, it'll be full of bacteria. And you don't have to worry about what's in one loopful or one stupid drop that you make. You want a xylol concentrate. It makes a lot of difference. Well, leprosy, tuberculosis hasn't been cured, and oddly enough, leprosy hasn't been controlled either. Even third world countries, there's still some, I mean, even in countries that aren't third world, there's still some problems. And this organism doesn't grow for you in the classic stage. It only grows in the L. And we have grown it. We didn't get blood from human lepers. We got it from animals, and I'm not allowed to say where. But we could grow it in a method we like to use. And we didn't invent this, but it's a well-known method. You can grow bacteria on slides, just slide culture. So you flame a slide to sterilize it, and you spread a loop very nicely, so parts thin and parts thin, or you can use a whole drop, but just so you don't have it too thick. And then you put it in culture medium. The first time we did this, we were trying to stain the TB organisms, the mycobacteria, in auramine rhodamine, and our L forms don't stain in auramine rhodamine. But the point is, the stupid things grow. So this is, you can use a medium with auramine rhodamine in it, which has about 6% phenol, and they grow in 24 hours. And the nice thing is, you can, looking at it unstained, you can see hemolytic areas sometimes and see how many organisms were in that drop. And it gives you a quantitative estimate too. And of course you can stain it. This is a Copland jar. The hematologists, as you know, use it to stain something that has to be stained more than a few minutes. So we thought if things don't stain in a few minutes, we'll leave it overnight, and sure enough, they grow. So all kinds of L forms. We love to grow Borrelia in this. And Borrelia, the organism of Lyme, isn't an anaerobe and it isn't an aerobe. It's a microaerophile. It'll grow someplace below the oxygen maximum, and you'll see an area that has the best growth of L forms, and then done clear in the anaerobic wood down here, and done clear up in the oxygen usually. So it's this very simple way to grow a microaerophile. This is Mycobacterium leprae on a slide culture, and you see it is hemolytic. Oh, I don't know whether I should bring this up or not. It's a big subject, but we spent quite a few years on this to make this a personal history. When we had only been married a couple of years, my husband had a coronary and nearly died. And he had pleural fluid develop as a result of his condition. And of course, I had to have some of that fluid, and I put it into guinea pigs, and they died. And we found we had an agent that could pass from guinea pig to guinea pig and produce pneumonia and death, but nobody could name it. I gave it to the best virologists. They said no virus. We could look for bacteria, no bacteria. We looked for L forms, no L forms. We looked for fungi, no fungi. Well, in Finland and some other places, they found the organism. It's Chlamydia pneumoniae. And you can say it's cell wall deficient. It certainly doesn't have a typical wall. But what my students showed was that all cases of coronary thrombosis have this organism in the pleural fluid, or the fluid that forms wherever it is, and it's the same Chlamydia pneumoniae. In other words, we got an antibody. We didn't know what antibody it was for, but we had a very good antibody to this organism. And I think the history of coronary thrombosis is interesting. For years it was known that there was this terrible pain that would occur in the chest and maybe the left arm, and they didn't know what it was. They would look and look. And one group of people thought it was, they called it a crisis of the liver, and remained unknown until a professor at Johns Hopkins University Medical School had a coronary, and then they took a real good look, and then they found the clot. So they knew it was due to a clot in the coronary artery. But anyway, why do I bother to tell you all about it? Because I think you could help perhaps in this problem. For one thing, I think children, particularly males, should be vaccinated against this organism, because I know from personal experience how terrible it is to suffer it. And I'm not going to say anything detrimental about the male sex, but unfortunately, males are born with arteries that are inferior to females, and that's why they're more susceptible to a coronary. So someday maybe this could be in the vaccination routine. But what I would like from all of you, if you have time to ever send me an email, is anything you could get that would add to all the anecdotes we have that this is a contagious disease. We have these kinds of anecdotes. 2 men who sorted mail in a small room were carried out on stretchers the same day. They had a coronary. A man whose companion in a 2-bedroom room in a hospital had a coronary. He got a coronary. So for all of you, I think the message here is, if you have a friend who suffers one of these, don't go and visit him and sit by the bed. Just make friendly telephone calls and let it go at that. Send him some flowers or do something else, because and the tragedy is that this is probably also the cause of a thrombus in the brain. And so maybe somebody with a coronary will give a stroke to somebody else, which is even worse than a coronary, of course. So it's something to stay away from. But what you can do in the way of helping everybody connected with, is interested in this, is see if you have any anecdotes that show the connection between having exposure and getting either a stroke or a coronary thrombosis. And there is evidence that a female, well-intentioned though she is, may become a carrier after 4.5 months. This has a 4.5-month incubation period, and that's why it hasn't been obvious. But then in 7 months, she may, in 9 months, 4.5 times 2, in 9 months she can be a carrier. For instance, she will go and visit her father, who's had a coronary, and then she'll give it to her husband, who 4.5 months after she gets full blown will have a stroke or a coronary. So anything you can connect in the way of anecdotes may help people to be sure that this really is an infectious disease. But we know very well what the agent is. This is an entirely different subject, and this is something really, I guess, only important for those who work in a hospital. The hospital buys sterile, distilled, triple distilled medium. It isn't just autoclaved, it's all kinds of things are done to purify it. And after they use a little bit of it in syringes, well, they use it to wash urinary catheters, all kinds of things. But they put it in the refrigerator, and they think everybody knows bacteria don't grow in water. Well, you all know now bacteria do grow in water. And in the hospital, there's a lot of Pseudomonas in the air because there are a lot of Pseudomonas infections, some of them minor, that aren't detected. And Pseudomonas is what we call a water bug. It's very happy in water. And so this is something that's grown in triple distilled water. The work on this was done by Stan Susan. He did a lot of good studies. These are colonies in a pore plate. It's better to always make a pore plate for L forms than to just streak the surface. And so these spiculated things, Judy Besser and other students worked on this. But they take this water that they think is sterile and use it to humidify an incubator that has newborns in it. Or they use it again for spinal anesthesia, and you know what happens. The point is, these are L forms. They won't grow in ordinary media that's supposed to be complete. And they won't grow on the surface of a plate. So you only find them in a pore plate with good medium for L forms. This is in case you didn't have enough coffee recently. This is another spirochetal disease, so we're getting to spirochetes. In the early 1960s, Haiti had an endemic outbreak of this. They concluded finally that everybody had yaws, and they didn't say under the law you must come in and get treatment. What they did was break into every house and treat everybody with a huge dose of penicillin. And we don't have a magic drug for Morelia yet. Maybe soon, but not yet. And so what this, the diseases, as you well know, caused by spirochetes are dreadful. Not just syphilis, that was endemic once in Paris, but they're not only dreadful diseases, they tend to become endemic, spread by non-sexual routes. And then we get to another different topic. This is parasitism of your red cells when you have Borrelia infection. And here's some more, just a different picture, the same idea, just lots and lots of intracellular growth. So you understand how they get hemolyzed cells and are going to feel miserable. And this is one, yeah, this is merely blood that was shipped. So it had a chance to grow in the shipping temperature, and we often find ship blood will give us a good picture without any more incubation. And here's another one. This is a blood culture. And this is another one. Every one of these cells is infected. And this is ear prick blood. If you can get a patient to let you use their ear, it's a lot more productive than the finger. I think that's odd, but they say there's stagnation in the ear, and if you can get ear prick blood, it's a lot better than venous blood or blood out of a vein. The first time I saw this was in blood from Sweden, and I reported that this patient who had received blood and smears on, we saw the Lyme organism. We could identify it. We could identify it. Would you get my cough drops? Okay. She got a cough drop for you. You could identify it with fluorescent antibody. But I said to Dr. Berg, I wrote him a note with the report of what he examining the blood. He sent me smears, and he sent me a tube of blood. And I said, these can't be direct smears. They're loaded with the L form of what is this organism. And he called me from Sweden and said, those are direct smears, I made them myself. And so then I realized that what's been found for most of these spirochetes, Texas fever and some others, anyway, we found in our own clinic, people can be walking around and feeling fairly normal. They don't feel good, but they aren't bedridden, and their blood can be loaded. It's just unbelievable what you can see in a direct smear. Well, I wanted to end this talk on a very cheerful note and talk about some things that can be used to identify these rapidly. Of course, fluorescent antibody is one. And you can see this even in direct blood sometimes. Of course, cultures are better. Oh, this is a different topic. These are some fluorescent spirochetes in a pleomorphic colony in semen. So if a male is infected, his semen is very apt to be infected. And this is now the most important cause of congenital diseases. Not syphilis, which used to be true, but the organism of Lyme disease. And this is just data from one hospital saying that 1/6 of their patients who were newborn fatalities had died because of Lyme. These are autopsy findings. Then we get to a different topic, and this I think is too bad and perplexing. It takes an awful long time for the world to accept anything new. A derogatory article will be published by any journal right away, a negating article. But one with anything new, they're scared to death to publish. And but Vincent Marshall, who some of you know of, was a veterinarian who studied a lot of things, and including the spirochetes, in his vet lab. And this is from an article he wrote, the same thing is in my book. But look at all the countries where they had proof that there was a spirochete in multiple sclerosis. So this is MS. From France and from the United States, it was Steiner and Wayne State who did it. And in Germany, And not only did they find the spirochete in MS, but they were able to do Koch's postulates. I think you all know what Koch's postulates are, that you have a culture that you got from a patient's specimen, you put it into an experimental animal, you get a disease, you get illness, you take it out and you find what you injected, you know it was the pathogen. And so often you get the same kind of disease. Well, so they confirmed it in monkey, and Vincent Marshall did it in all his small animals, mice and rats and hamsters. And Steiner did it using a silver stain. He looked at autopsy tissue from the brain of MS patients, and that's been confirmed in Austria and many parts of Europe. So why on earth don't people know that MS is not due to a virus, it's due to a spirochete? And I'm going to show you what the spirochete looks like and how easy it is to show that. This is uncentrifuged spinal fluid. It's so loaded that you see a spirochete in MS spinal fluid. You know, that's one good thing about this. I said we had a happy note here. Anyway, so very often there are so many organisms present in these spirochetal diseases that all you need to do is incubate the sample. It's the best culture medium. What could be more simple? And it'll even go in the refrigerator sometimes. But it's better to put it at 35 degrees. So you don't have to say, oh, I couldn't make up that fuzzy medium. All you need to do is take 1 ml of it and incubate it and see what grows. So there's, you know, the textbooks say, don't even try to grow spirochetes. You can't, you just mistake fibrin for spirochetes. And you can tell fibrin from spirochetes by using acridine orange, and we'll show you that in a minute. This is fluorescent antibody showing that this is blood, right? You can see that better.
Long refrigerated blood, refrigerated blood.
Yeah, it's just blood that was stored. And see, they didn't even need 35 degrees. They grew. And this is antibody to Morelia Burgdorferi. So why on earth won't people accept this? There is a table published of how long it is before something is demonstrated before it's accepted. We call these people that don't accept it brass monkeys. But anyway, there are an awful lot of them out there. But this is not our finding, but the work from the Brorsons, B-R-O-R-S-O-N, in Norway. That's an interesting couple. He's an MD and she's a PhD, and they publish articles on work that they've accomplished together. They were the first to show that you can learn a great deal by looking for the cystic form, not the spirochete. The spirochetes all look pretty much alike. We know now they're not identical, but anyway, they're all a spirochete. And he found these cysts in multiple sclerosis, in the spinal fluid directly, and in spinal fluid cultures in BSK medium. And this brings me to a sad point of something that made me cry. Well, it's been quite a while ago. But when we published our paper showing we could grow spirochetes, something came out from, well, a prestigious source that said that they couldn't grow any spirochetes. You know, there's nothing easier in the world than not growing them if you don't do it right. And so why didn't they call us and ask? We published, Steve Phillips was the senior author. I don't mean to sound like paranoid, but to get an article published in a medical journal in the United States, the senior author should be an MD male. And so Steve was our senior author, Steve Phillips from Connecticut. So we published this paper, our wonderful MPM medium, that would grow spirochetes. And an article promptly came out. We couldn't grow anything. We tried and tried. We held it for weeks and weeks, and we looked for spirochetes and didn't grow any. Well, why didn't they call us? Another lab had a negative finding, and they called Dr. Phillips, and he said, it's probably the final pH. You don't have it quite right. It's got to be alkaline. And so they called him a few weeks later and said, they're growing like crazy. So why didn't they call me and get it straightened out? Anyway, for all those who have asked, I've made copies of our medium for anybody who wants to grow spirochetes. But also the precautions. There are about 8 things you can do wrong. And one of them is to use medium when it first comes out of the autoclave. You think, oh boy, freshly autoclaved medium is going to be the best things. They think it's hydrogen peroxide that forms, and it won't let anything grow till it dissipates, which happens in 1 day later you can use it. But you can never grow a spirochete on medium freshly autoclaved. And there are 8 other things you can do that will ruin your chances of growing them. Well, I call this backpacks. It doesn't show on here, does it? Well, anyway, you can see round cysts, and they have material on the outside of their membrane. And so we confirmed the work of the Brorensons, but we carried it a bit farther because our medium, MPM medium, is better than a BSK because it will grow from the blood of an MSK. Who likes to have their spinal cord punctured? People object to spinal punctures, but everybody's used to an IV. So we can grow it from the blood using our medium and don't have to use spinal fluid. We have looked at 40 MS cases and the blood cultures on 40, and they all have a spirochete which reacts with Morelia antibody, Morelia Burgdorferi. But the fact that they make these cysts show that they're not Borrelia, because the cysts of Borrelia are different, and I'll show you some. Oh, this first is a spirochete of MS, and the secretary had a bad finger there. It's supposed to be encapsulated. They're surrounded by a capsule. So these spirochetes grow the cysts inside and then expel them. So this is like a string bean that has little bodies inside it. And in all the spirochetes, you can find the cysts developing first in the spirochetes. Well, this is plain old Lyme disease. And in Lyme, there are 2 kinds of cysts. This is one of them, these rectangular things. And they're attached to the spirochetes with fibrii, thin little filaments. This is the other cyst of Lyme disease. This doesn't in any way resemble the cyst of MS, does it? So, and I have to say here that this excellent work on electron microscopy was done by anybody who I think is the best, is as good as any electron microscopist in the world. And her name is Carol Ayala. She's at the Core Research Lab in Providence, Rhode Island. So this is all the work from there. Well, this is another interesting disease and unknown etiology, This is what you will find in the blood of any Lou Gehrig's disease. And this will grow in 48 hours as sure as the sun comes up in the morning and sets in the evening. You have to have precautions, inoculate it right, do everything correctly. But once you learn how, there's nothing easier to do. So, and these are the same cysts forming in the spirochete. And this is something else about ALS, the other name being Lou Gehrig's. The fimbriae, in some cases, we have 4 cases altogether, are segmented, they're broken into pieces. And that's true in the cases we get from other countries as well as the United States. So the symbol of Lou Gehrig's is the segmented, the hyphenated fimbriae. I have a cigarette cough and I never smoked. It isn't fair. But this is just some of the fluorescent antibody reactions. You always get them. The morphology is pleomorphic, of course. But in all these diseases we're going to talk about, they all react with Morelia Burgdorferi antibody, but the cysts show they're different. So they're in the same genus but different species. And then we get to another organism. This is the one of Parkinson's. For decades considered of unknown etiology. We only have 5 cases. Fortunately, Parkinson's is rare. But in all 5, we find there are 2 types of cysts. This is one of them. And this is the other. And for many of you here, I've handed out copies of these electron micrographs, and I'll give them to anybody else who wants them. A good point that I want to make on this is that these reacted with Morelia Burgdorferi antibody that was labeled with gold. So first these were treated with Morelia antibody that was unlabeled, that was made in rabbits. I'm sorry, I missed something wrong a minute. Anyway, first it got unlabeled antibody made in rabbits to Morelia, so it attached. And then, after that was washed away, it was treated with gold-labeled antibody to rabbit serum. You get the point, it's indirect antibody. It's, a lot of people like it better than fluorescent. I don't know why I like fluorescent better, but apparently this works better for electron microscopy. So the little black specks in there are gold-labeled antibody to rabbit serum, which was made in a rabbit, and therefore had to attach. So that's true of all of these, that the cysts show they're different, but they're in the same species since they react with antibody to Burgdorferi, to Morelia Burgdorferi. They're all in the Morelia genus. Well, here we get to something nice and simple. And this is ways to recognize these things without fluorescent antibody or gold-labeled antibody. The best simple stain to use is Killian's carbylfuchsin. And it's easy to buy. And spirochetes don't like to stain with a Giemsa stain. You'll never see them with Giemsa. You'll never succeed with the Graham stain. But with carbylfuchsin, you will. The spirochetes do one of 2 things. They either adsorb it or they're revealed by negative staining. These are revealed by negative staining. This is a 10-day blood culture. And all the little tiny things in there, if you can see it up close, are spirochetal. And there's one giant one. The giant forms in bacteria are called polyploidal. They think they have more than one nucleus, of course. This is negative staining again. The organism hasn't stained, but the background has. And this is an ALS, Lou Gehrig's, and this is a colony of what, with a little imagination, you can call spirochetes. So you can use kinioids to good advantage. And here's something else that the ordinary lab can do. They don't even need to have a UV scope. They can use acridine orange. And acridine orange does not stain fibrin. It doesn't stain your debris. It only stains nucleic acids. It's easy to remember. It stains RNA red. So an organism that's multiplying stains red, and one that's just resting stains green. Well, here you have organisms that are not multiplying anymore, but this is some organisms that were inside red cells, but not multiplying, but they did show, and every red cell in there seems to be infected. A red cell, as you have it, as you know, does not normally have a nucleus. They discard their nucleus as they leave the bone marrow. So this is in highly, highly infected blood. And this is a colony stained with acridine orange and concentrated with xylol. And if you can see this closely and so forth, the edge of this is made of spirochetes. This is a colony in urine. We get to the ways that Burgdorferi is transmitted. I laugh at all this stuff about looking for the wood tick. That's so ridiculous, because most of the people who get Lyme disease have never heard of or seen a tick. And we know now it's in tears, and people wipe their eyes, and then you shake hands with them. Or we don't laugh so hard about the physician we had in a hospital who wouldn't touch the doorknobs in the hospital without taking his coat, his white coat, and handing the doorknob through a coat. Maybe he wasn't so insane after all. So we think this is spread by what are just called fomites, which is the pencil in the bag as you pick up a pen, as you pick it up to write a check, or anything you handle. And so it's in urine, it's on tears, and also it's spread by mosquitoes. And who hasn't had a mosquito bite? We've tested the mosquitoes in Michigan, and sure enough, they can carry, and some of them carry, the Lyme spirochete. Oh, this is very interesting. I thought this is a culture of that dreadful spirochete of Lou Gehrig's. And it's stained with acridine orange, and it's staining red, showing they're still full of pep and multiplying, and it's a 10-day culture. We repeat this with the spirochete of Lyme or MS, and in 10 days they're only green. So if you have your choice, you're not going to take this one, are you? Lou Gehrig's is your last thing you'd want. And this is something else for the ordinary lab that doesn't have fluorescent antibody. This is a simple stain, Bismarck black B. Sudan black B, I'm sorry, Bismarck is something else. Sudan black only stains a few things. It stains Pseudomonas. Well, you don't run into Pseudomonas in the average patient. And so Sudan black B is something you can purchase. It doesn't cost very much money, like a fluorescent antibody does. that is very useful. That's probably my last slide. That's my last slide. Okay, that's the way all of us feel about it.
Drink some more water. You sound so hoarse.